This is SpaceTime, Series 23, Episode 3. Coming up on SpaceTime. Is the red supergiant Betelgeuse about to blow? Discovery of the earliest known examples of cannibalism. And China launches its most powerful rocket ever. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The red supergiant Betelgeuse is dimming rapidly, and astronomers don't know why. Strange activity is causing growing speculation in the astronomical community that Betelgeuse may be about to blow. Then again, probably not. Betelgeuse is a semi-regular variable star, located some 643 light-years away in the constellation Orion the Hunter, which this time of the year is located in the northeastern sky. Calculations of its mass range from slightly under 10 to a little bit more than 20 times the mass of our Sun, and it has some 100,000 times the Sun's luminosity. In fact, Betelgeuse is so huge, were it located where the Sun is at the centre of our solar system, its surface would extend out almost as far as Jupiter, engulfing the orbits of Mercury, Venus, Earth, Mars, and the main asteroid belt. Betelgeuse has always been one of the largest and most luminous stars visible with the unaided eye. Until recently, it was the 9th brightest star in the night sky, and the brightest star in Orion, representing the scorpion's sting on Orion's shoulder or armpit. But it's only about half as bright now as what it was 5 months ago, and is in fact the faintest it's been in a century. That means it's dropped from 9th down to just the 21st brightest star in the night sky. Betelgeuse is thought to have a complex and tumultuous surface that frequently throws out impressive stellar flares. Astronomers have been watching Betelgeuse brighten and dim over and over again for more than a century. Dimming is normal for semi-regular variable stars like Betelgeuse. But it's the rate of dimming during this latest episode which is so unusually rapid. Based on Betelgeuse's past dimming and brightening patterns, it appears to cycle in brightness through two co-occurring patterns, a short period cycle lasting 425 days and a longer cycle lasting 6 years. Now, as these two separate patterns superimpose upon each other, they occasionally sync up, and that's exactly what's happening right now, and that could explain the rapid dimming. Now, if all that holds true, then Betelgeuse will reach its faintest in the next few weeks, and then start to brighten again. The big question on everyone's mind, however, is whether it's about to explode as a core collapse Type 2 supernovae, and that idea isn't all that far-fetched. See, Betelgeuse began its life as a blue giant about 10 million years ago. Now, astronomers think stars of Betelgeuse's mass usually live for somewhere around 8 to 9 million years. They burn through their nuclear fuel really quickly compared to a dwarf yellow star like our Sun, which will live for maybe 10 or 12 billion years. So, if Betelgeuse is 10 million years old, and stars like Betelgeuse usually live for about 8 or 9 million years on average, then it could very well go supernova any day now. Of course, in astronomical terms, any day now could mean tomorrow, or it could mean in a million years' time. When it does explode, it'll temporarily outshine all the other stars in the galaxy, easily outshining the Moon, and it will be clearly visible in the daytime sky from Earth. The last star seen by humans to go supernova in our galaxy was Tycho's star back in 1572, and that was before the invention of the telescope. And before we go, we better clear up the name. It's currently referred to by astronomers as Betelgeuse, which has been commonly corrupted to Betelgeuse. Don't say it 3 times. Both names are actually tortured mispronunciations of its original Arabic name, Betelgeuse, meaning the hand of the big man. The big man, of course, being Orion the Hunter. There's a lot astronomers still don't know about the behaviour of variable supergiants like Betelgeuse, so any strange activity, such as what's happening now, provides them with a chance to learn more about the lives of these truly massive stars. Needless to say, we'll be keeping a close eye on it too. You're listening to SpaceTime. Still to come, discovery of the earliest known example of cannibalism. We discover how well you really know our place in the Milky Way galaxy, and China launches its most powerful rocket yet. All that and more coming up on SpaceTime. Astronomers have discovered the earliest known example of galactic cannibalism, an observation dating back some 13 billion years. The findings, reported on the pre-press physics website archive.org, provides another piece in the puzzle of galactic evolution. Galaxies grow through merging with or consuming other galaxies. Stellar streams in our own galaxy, the Milky Way, point to how our galaxy has grown to its present size through exactly the same process. And even today, the Milky Way is busy cannibalizing at least 3 other small satellite dwarf galaxies. The Sagittarius dwarf, which is on the other side of the galaxy from where we are, and the Large and Small Magellanic Clouds, both of which can be seen in the southern hemisphere night skies. And in another 3.7 billion years from now, the Milky Way itself will be cannibalized by an even bigger galaxy, M31 in Andromeda. Now, astronomers are pretty certain that galactic mergers must have been occurring right throughout the entire evolution of the universe, but exactly when did it all begin? It's logical to assume it would have been the very early cosmos. That's when the universe was more compact and things were all a lot closer together to each other. But exactly when? Now, astronomers using ALMA, the Atacama Large Millimeter Submillimeter Array Telescope in Chile, have observed spectral signatures of oxygen, carbon and dust from a galaxy catalogued as B14 65666, located some 13 billion light-years away in the direction of the constellation Sextans. This is now the earliest galaxy where this useful combination of 3 signals has been detected. By comparing the different signals, the authors determined that the galaxy is actually 2 galaxies merging together, making it the earliest example of merging galaxies ever discovered. The study's lead author, Takuya Hashimoto from Waseda University, says because of the finite speed of light, the signals received from B14 today by ALMA have travelled for more than 13 billion years to reach us. Now that means they're showing what the galaxy would have looked like 13 billion years ago, just 800 million years after the Big Bang. The data analysis showed that the emissions are divided into 2 separate blobs. Now, previous observations with the Hubble Space Telescope revealed 2 star clusters in B14. But now, with the 3 emission signals detected by ALMA, Hashimoto and colleagues were able to show that the 2 blobs do in fact form a single system. But importantly, they're moving at different speeds, and that means the 2 blobs are in fact 2 separate galaxies in the process of merging. And that's what makes this the earliest known example of merging galaxies. The authors estimate the total stellar mass of B14 is probably less than 10% that of the Milky Way, and this means that it must be one of the earliest phases of its evolution. B14 is producing stars 100 times more actively than the Milky Way, and such active star formation is another important signature of galactic mergers. That's because gas in these galaxies is being compressed by the collision that's triggering starburst, the formation of lots of stars. Hashimoto says the combined data of ALMA and Hubble, together with advanced data analysis, allowed astronomers to put the pieces together to show that B14 is a pair of merging galaxies in the earliest era of the universe. Mergers are essential for galaxy evolution, so astronomers are eager to trace back the history of galactic mergers. The authors are now turning their search to the hunt for nitrogen and carbon monoxide, 2 other telltale chemical signatures seen in galactic merger events. We'll keep you informed. You're listening to SpaceTime. Still to come, China launches its most powerful rocket ever. And later in the science report, scientists think they've worked out why whales can get so unbelievably huge. All that and more still to come on SpaceTime. Okay, so we all know that we live in a small terrestrial planet orbiting a yellow dwarf star in the Milky Way galaxy. But what do you really know about the Milky Way galaxy and our place in it? Here's what most people don't know. Our Milky Way galaxy is what astronomers refer to as a barred spiral. It contains an estimated 1.5 trillion solar masses. It has an overall diameter of around 258,000 light-years. On average, it's approximately 1,000 light-years thick and contains an estimated 100 to 400 billion stars, 10 billion white dwarfs, a billion neutron stars, and 100 million black holes. The solar system is located at a radius of about 27,000 light-years out from the galactic center, on the edge of the Orion Arm, one of the many spiral-shaped concentrations of gas and dust which characterize a spiral galaxy. The Sun orbits around the galactic center approximately every 240 million years. The stars in the innermost 10,000 light-years from the galactic center form a bulge, and one or more bars that radiate out from the bulge. The galactic centre contains an intense radio source known as Sagittarius A star, which is assumed to be a supermassive black hole with about 4.3 million solar masses. The Milky Way's galactic plane is inclined by about 60 degrees to the ecliptic, that's the plane of Earth's orbit around the Sun. The Milky Way consists of a bar-shaped core region surrounded by a warped disk of gas, dust and stars. Now, the disk of stars in the Milky Way doesn't have a sharp edge beyond which there are no stars. Instead, it's simply a case of the concentration of stars decreasing with distance from the centre of the galaxy. For reasons not yet fully understood, the number of stars per cubic parsec drops much faster with radius beyond a radius of roughly 40,000 light-years from the galactic centre. Interestingly, stars and gases at a wide range of distances from the galactic centre all orbit at roughly 220 kilometres per second. Now that's interesting because such a constant rotational speed regardless of radii contradicts the laws of Keplerian dynamics and suggests that around 90% of the mass of the Milky Way must be invisible to telescopes, neither emitting nor absorbing electromagnetic radiation. And that suggests that most of the Milky Way is composed of dark matter, that mysterious substance which interacts only gravitationally with normal or baryonic matter, the stuff that stars, planets, houses, trees, dogs, cats and people are made of. Surrounding the flat galactic disk of the galaxy is a spherical galactic halo of stars and globular clusters, which extends much further outwards, but is limited in size by the orbits of two of the Milky Way's satellite dwarf galaxies, the Large and Small Magellanic Clouds, whose closest approach to the galactic centre is about 180,000 light-years. The oldest stars in the Milky Way are population 2 stars, more than 13 billion years old. That's nearly as old as the universe itself, and thus probably formed shortly after the dark ages of the Big Bang. The Milky Way galaxy is moving through the universe with a velocity of approximately 600 kilometres per second with respect to extragalactic frames of reference. And it's not alone. The Milky Way has around 50 satellite galaxies, and it's the second largest galaxy in our local galactic group, the largest member of which is the M31 galaxy in Andromeda. This local group of galaxies, of which the Milky Way is just one small part, forms part of the Virgo supercluster, which itself is a component of the larger Laniakea supercluster. Almost all the stars you see when you look up into the night sky are located within the Milky Way's Orion Arm. The Orion Arm, or Orion Spur, or even Orion Cygnus Arm, depending on which name you prefer, is about 10,000 light-years long and some 3,500 light-years wide. It's named the Orion Arm after the Orion constellation, which is one of the most prominent constellations in the Southern Hemisphere summer and Northern Hemisphere winter night skies. The Orion Arm is located between the Carina-Sagittarius Arm, which is more towards the galactic centre from where we are, and the Perseus Arm, which is more towards the outer edge of the galaxy from our point of view. The Perseus Arm is also one of the two dominant arms of the Milky Way, the other being the Sanctum Centaurus Arm. The Orion Arm was long thought to be simply a minor structure or spur between the two longer adjacent arms, Perseus and Carina-Sagittarius. But evidence was presented in 2013 that the Orion Arm might well be a branch of the Perseus Arm, or possibly even an independent arm segment itself. Our solar system, including the Earth, is located about halfway along the Orion Arm, close to the inner rim, in what's known as the local bubble. The local bubble is a cavity in the interstellar medium within the Orion Arm, containing, among other things, the local interstellar cloud, which contains our solar system and the G-cloud. It's at least 300 light-years across and has a neutral hydrogen density of about 0.05 atoms per cubic centimetre. And that's just 1/10 of the average density for the interstellar medium within the Milky Way, and about 1/6 that of the local interstellar cloud. The hot diffuse gas in the local bubble emits X-rays and is the result of a supernova that exploded within the last 10 to 20 million years. It was once thought that the most likely candidate for the remains of this supernova was Geminga, a pulsar in the constellation Gemini. More recently, however, it's been suggested that multiple supernovae in a subgroup known as B1 of the Pleiades moving group were more likely responsible, becoming a remnant supershell. Our solar system has been travelling through this local bubble for the last 5 to 10 million years. Its current location is in the local interstellar cloud, a minor region of denser material within the bubble. This cloud formed where the local bubble and another bubble called the Loop 1 bubble meet. Gas within the local interstellar cloud has a density of approximately 0.3 atoms per cubic centimetre. The local bubble isn't spherical, but seems to be narrower in the galactic plane, becoming somewhat egg-shaped or elliptical, and may widen above and below the galactic plane to become more like an hourglass in shape. And it abuts other bubbles of less dense interstellar medium, including the Loop 1 bubble. By the way, the Loop 1 bubble was created by supernovae and stellar winds from the Scorpius-Centaurus Association some 500 light-years away. And it's easy to spot the Loop 1 bubble because it contains the star Antares, the antithesis of Mars. There are several tunnels, collectively known as the Lupus Tunnel, which appear to connect the cavities of the local bubble and the Loop 1 bubble. Other bubbles which are adjacent to the local bubble are the Loop 2 bubble and the Loop 3 bubble. Now, what all this is showing us is that our region of the universe is far from empty. The Milky Way is a special feature in Australian Sky and Telescope magazine. Joining us now with the details is the magazine's editor, Jonathan Nally.
So the Milky Way is actually a pretty big galaxy as galaxies go in our universe. It's one of the giants. From end to end, or from side to side, our galaxy spans well over 100,000 light years. Most figures I've seen say 120,000 light years wide. Some say 150,000 light years wide. Some say even a bit bigger. So it's a really big galaxy.
It depends whether or not you include the halo as well, but I take it you're just talking about the extent of stars that we can see.
That's right. If you include the halo, you can probably say 200,000 light years wide or something like that. In fact, so huge is our galaxy that almost all the stars in our galaxy are so far away that you can't see them with the naked eye. The ones you can see with the naked eye up there in the night sky are pretty much all of them within just the local spiral arm in which our solar system lives.
And that's the Orion spur, isn't it?
Yeah, the Orion one, the Orion arm, you can call it. Most astronomers just call it the local arm, because that's the one we live in. They're very imaginative sometimes with their naming. The Milky Way, we think, has 4 main spiral arms, all sort of winding out from the central regions of the galaxy. Some people say a starfish is not really the right thing. You know those garden sprinklers that have got sort of 4 spouts that spin around, and as you spin around, the water sort of swirls? It's a bit like that, but much, much slower, of course. And if you were to get above our galaxy, above the sort of northern part of our galaxy and look down, you would see the Milky Way just slowly spinning clockwise if you could stay there for a very, very long time looking at it. I think it takes, about 200 million years, they reckon, to do one full spin. So it's a big, slow, majestic, twisting spiral galaxy.
Have they worked out yet whether it's as big as Andromeda, our biggest nearby neighbour? Andromeda's huge. Most estimates say it's much larger than the Milky Way. But lately there's been a lot of debate as to whether or not there is much of a mass difference between the two.
I know for a long time people have said that Andromeda's much, much bigger, and yes, I've heard the same sort of thing, that maybe the size difference needs to be adjusted a bit, but my feeling is, from what I've read, that they still think that Andromeda is bigger. Yeah.
Oh, well, we'll answer that question about 3.7 or so billion years from now when the two come together.
Just can't wait. That's
Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. I'm Stuart Gary. The United Launch Alliance says its new Vulcan Centaur rocket is on track to have its maiden flight next year. The first completed launcher is expected to be moved from the company's Alabama production line to Cape Canaveral for process preparation later this year. The United Launch Alliance was created as a joint venture between Boeing and Lockheed Martin in 2006. By this time, Lockheed Martin had already phased out its famous Titan launch vehicle, inherited years earlier from Martin, in favour of Lockheed's own Atlas launch system, which it brought into the new United Launch Alliance joint venture. Meanwhile, the other half of the alliance, Boeing, brought its daughter launch system into the new partnership. And the two separate launch systems have been running parallel ever since. The new 59-metre-tall Vulcan Centaur is designed to replace both the Atlas and Delta with a new single rocket launch system. The Vulcan first stage will share the 5.4-metre diameter of the Delta IV Common Core booster. But it will use Blue Origin's new BE-4 engines burning liquid methane and liquid oxygen propellants instead of the Delta IV's liquid hydrogen and liquid oxygen engines. The Vulcan core stage can be fitted with up to 6 strap-on solid rocket boosters, allowing it to lift up to almost 35 tons into low Earth orbit and more than 7 tons into geostationary orbit. Vulcan's upper stage will use an upgraded variant of the common Centaur 3 booster, which is currently used on the Atlas V. Vulcan will undergo human rating certification. That will allow it to carry both Boeing's CST-100 Starliner, which is currently being launched on Atlas V's, and the new Sierra Nevada Dream Chaser spacecraft as well. The Vulcan Centaur's maiden flight is slated for July 2021 from Space Launch Complex 41 at Cape Canaveral, carrying the Peregrine lander on a mission to the lunar surface. China has carried out a successful launch of its most powerful rocket, the Long March 5. The 57-metre tall launch vehicle blasted off from the Wenchang Satellite Launch Center in the southern Chinese island of Henan, carrying the new Shijiang-20 experimental high-throughput telecommunications satellite. It's only the third time Beijing has flown the Long March 5. Its last flight in 2017 ended with a multi-million-dollar mid-launch failure and the destruction of both the launcher and its Shijiang-18 satellite payload. And that led to the grounding of the Long March 5 for 2 years. The Long March 5 is designed to carry payloads of up to 25 tons into low Earth orbit and nearly 14 tons into geostationary transfer orbits. The rocket's core stage uses 2 liquid hydrogen and liquid oxygen YF-77 main engines, which burn for nearly 8 minutes, and 4 liquid-fueled kerosene and oxygen strap-on twin-engine boosters. The failure of the previous mission was traced back to the design of the YF-77 main engines, and that design has now been modified. The Long March 5's upper stage uses 2 liquid hydrogen and liquid oxygen YF-75D main engines to carry the payload the rest of the way to orbit. As for that payload, the Shijiang-20, well, it's the first spacecraft based on Beijing's new DFH-5 telecommunications satellite platform. And it will replace the Shijiang-18, which was lost during the last Long March 5 launch attempt. China had successfully launched its first Long March 5 back in November 2016. The official Chinese Xinhua news agency claims this successful flight will pave the way for the Long March 5 to be used on future key missions, including launching China's first Mars probe, flying the Chang'e 5 lunar probe, and launching a core module for Beijing's new space station in 2022. Beijing has been investing billions of dollars into its space program. In fact, it's now spending more on space than Russia and Japan combined. In 2003, it became only the third nation after the Soviet Union and the United States to put a human into orbit. And exactly a year ago, in January 2019, China became the first nation to land a probe on the far side of the moon. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Researchers have found that the impact of losing intact tropical rainforests is far more devastating on climate than previously thought. A study by the University of Queensland has revealed that the clearance of intact tropical rainforests between 2000 and 2013 has resulted in a much higher level of carbon being emitted in the atmosphere than first believed. The data, reported in the journal Science Advances, has shown that it's resulted in a 626% increase in the calculated impact on climate. A new study has found that the emissions of the potent greenhouse gas nitrous oxide from rivers and streams has been increasing dramatically since the 1900s, largely thanks to the use of nitrogen-based fertilizers in agriculture. A report in the journal Nature Climate Change has found that small rivers were the main contributors to global nitrous oxide emissions from rivers and streams. Tropical regions and areas with intensively cultivated croplands, such as the central United States, Europe, India, Southeast Asia and East China, were the major sources of river nitrous oxide emissions. On the plus side, these emissions have declined since the early 2000s. But the authors warn this is largely due to plant growth being boosted to higher levels by another greenhouse gas, carbon dioxide, in the atmosphere. A new study has warned that eating more ultra-processed foods, such as cakes, ready meals, sweetened breakfast cereals, burgers and hot dogs, has been linked to an increased risk of developing type 2 diabetes. The findings, reported in the Journal of the American Medical Association, looked at over 100,000 people. Researchers found that those with a higher proportion of ultra-processed foods in their diet were also at higher risk of type 2 diabetes. Scientists think they've finally cracked why whales are so unbelievably huge. It turns out, like most other animals, the gargantuan size of whales is determined by the balance between the energy they can get from their foods and the energy they need to expend in order to get food. It's just that whales are able to gobble up so much more than other animals. The researchers tagged and tracked hundreds of whales and found that toothed whales are limited in size by how much they can eat during one deep-sea dive, while toothless whales are limited only by how much krill they can gulp, rather than prey availability. You can read the findings in full in the journal Science. Archaeologists have discovered 2 Bronze Age tombs containing a trove of ancient engraved jewellery and artefacts that promise to unlock secrets about ancient life in Greece. The 2 beehive-shaped tombs were uncovered in the Phylos region of Greece during excavations of the tomb of the Griffin warrior, a military leader buried with armour, weapons and jewellery. Archaeologists from the University of Cincinnati who made the discovery say that just like the Griffin warrior's tomb, the newly found tombs also contain a wealth of cultural artefacts and delicate jewellery that could help anthropologists and historians fill the gaps in science's knowledge of early Greek civilization. The Griffin warrior was so named for the mythological creature, the griffin, part eagle, part lion, which was engraved on an ivory plaque in his tomb, which also contained armour, weaponry and gold jewellery. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.